opportunities and many things, learning new trends you get to lay hands on in the geospatial community group. Now, there is something like this, or like every 2 weeks, bi-weekly, we have hands-on practical sessions, especially on the geospatial tools, and the recent ones, so to say. Now, also, we have times that we engage in hackathons and win prizes. So I just want to stay tuned. If you're not on the geospatial group, of course, you can access it through links. So, and without further ado, I'll be bringing in our facilitator for today, in person of Olatuji Gabriel, and who'll be taking us on the multi-criteria value analysis. Gabriel, you're welcome.
All right, thank you, Gideon. Good afternoon, everyone. I'm so glad to be here. I hope our day is going well. Yeah, so basically, what's multi-criteria value analysis and how is it applicable to solving geospatial problem? Right. So, basically, this particular session is for us to identify suitable areas for development that are closer to roads, away from water bodies, and not in a protected area. So there are three different criteria here, right? So how can we implement this using GIS tools, right? For us to be able to say that, okay, we have a particular input data, we want to locate areas that are suitable for development. So, and those areas is based on three criteria here, right? And one of them is how closer that area is to the road and how far away it is from water bodies, and if that area is in a protected area, right? So that's basically what we want to solve, right? So trying to bring this, introduce us to this particular problem is for us to easily identify what's the essence of multi-criteria overlay analysis, right? So now the question is, what is multi-criteria overlay analysis? It is the process that involves allocating areas based on various attributes that the selected area should possess, right? Just as we've seen in the introduction, right? How close that area is to the road, how far it is away from the water, and if it is in a protected region. Yeah. So, although this is a GIS operation, it is best performed in a raster space using grid-based approach, right? So basically, data we have available at the moment is in vector formats, right? But multi-criteria value analysis is best applied on raster datasets. So we're performing some operations, right, for us to be able to use raster datasets. So therefore, we have to convert from the vector data to raster data and then perform our multi-criteria value analysis on QGIS. Yeah, it's basically going to be hands-on, and as we solve the problem, I'll be explaining the concepts also. Starting with QGIS. All right, so here's our QGIS. And for us to locate the data sets, it's in my window desktop. So the data set is in my window desktop, and so I have to locate my window desktop now and then pull all of the data sets that will be used. Okay, currently, I already started my QGIS and I already have the data set in a shared folder, right? So what I'll need to do is to bring in the QGIS, the vector data into QGIS, and then we'll start working with those data on QGIS, right? So here's our data set, and we have uh, so if you look at this particular QGIS, we have um, 5 different vector data sets here. We have the boundary data set. I'll bring the boundary data sets into the QGIS panel and all the protected regions. So basically, we already got the idea of why we are doing multi-criteria overlay analysis, and there is a data needed to solve or to apply that analysis technique, right? And the major problem was that we want to locate areas, right, that are closer to the road, far from water bodies, and that area is in the protected regions, right? So there are 3 criteria here. Firstly, the road, the water bodies, and protected regions. So we got all data for that. And then the boundary of those criteria. So now the data is already being stored in a shared folder, right? And this is QGIS. So I just dragged the data into QGIS panel layer. On this layer panel, we already have the roads. I've already dragged the roads, the protected regions, and the boundary. And the remaining ones, which is water polygons, I'll do that now. So we drag it in here, and also for the water polylines, we drag it in here, right? So basically now this particular data is in uh, um, this particular data is in vector format, right? And for us to convert it asset, for us to convert which we can easily offer over analysis, which is best for raster data. Right. So now the next question is we have to convert each of these. We have to convert each of these um, vector data into raster. So what we need to do is to convert vector data to raster data set. Once you click on these 2 boxes, so we have to so after opening QGIS to go to GDAB. I search GDAB here, and then we can vector for vector conversion. And now that we have vector conversion, this rasterize vector to raster. This is relevant because this is raster data set, right? Grids of pixels, zeros, and one. So we'll say of 1 where there is road and value of where there is no road. Having road vector data. So in this part here, I'll change this to road, the input to roads, right? To roads. And then we'll do feed to use, right? So we have to choose fit to use for the data sets, right? So we have layer, fixed value to bond, right? And then we'll set fixed value to bond to 1, right? So we can just edit that from what it was initially to 1. And output raster size in it, we'll set it to the reference. So for this width value, which is width horizontal resolution, we use 15 meter. Okay, so we use 15 meter here, and height, same thing for the height, right? So we also use 15 meter. So it's going to be like a box, width of 15 meter, height of 15 meter. And then we have to choose an extent, right, for each of these raster data sets. And the extent we'll be using is the boundary data set itself, right? So click on this part here. Output extent. Right. So for the output extent, we'll calculate it from the available layers we already have. So we have to choose the boundary, right? So after choosing boundary as the output, um, extent, all we need to do next is to do run, right? So click on run, and it is going to load. And that is already loading. So one thing about QGIS is that so it has finished running, right? We can click on close. But one thing that it's best for us to actually save the vectorized data set and then to rename it, right? So like in our case now, we didn't rename it, right? We can as well do that here. Let's see what I can do. Yeah. So, okay, well, that's right. So that was right. I'll come back to that. And now the next thing is that now remember we have to do each of these steps for all of the vector data sets. So this for all of us can come soon, right? And but we actually utilize QGIS tools we allow us to convert more than one vector data into raster data one sum for right. So all we need to do to get the um, to what we did in it, but this time around we are not going to double it, but what we need is to write on that realize there. So this is what we need to do. The click on the motor values. What we need to do is to okay. So we leave that like this. This right. We actually right. Okay, so if you look at it, we already have one that we've already done before, right? So when I click on this, and I did field and use this for each of the um, class or select. So parameters you extent we are working with. And for the vertical, we are working with 50. And for the and we have G. This one for the bond, we have no not set. So it's how we use for that first one that we did that I'm setting right. Fit to value. Leave this one. For the bond from Z values features down to as no right.
Gabriel, can you hear me?
Fixed. So the fixed value to bone is one just like the value. So now after having that, yeah, thank you.
Delay.
So remember I converted. Okay, sorry. Remember I converted the roads vector data set to raster, right? And where I stopped was now trying to convert all of the other vector data to raster. So instead of doing it one by one, QGIS has the batch processing functionality to convert vector data to raster data, and that's where I'm currently on. So all you will need to do is for us to fill in this the first row. So firstly, I chose protected um, region, and then for this feed to use to bond. So I'm still basically using the same values I used for the road, the one I did earlier on, right? For the road vector data set, that's still the same value I'm using. I'm filling in here, right? So I'm filling in for the fixed value to bone. I've put in 1 day, right? And so this is basically saying like one for where there is road, right? And if there is no road, it will be 0 because we are currently working on the water vector data set, right? And for the field to bone, this particular value, leave it as default, and there's need for us to put the output raster size in it, and we chose georeferenced units. And there is also output horizontal resolution, put 15, the vertical resolution also 15, so that it is going, so that the pixel is going to be like a box, right? A square rather. And for the output extent, it is relevant, right? The output extent we are using is the boundary, because both the roads, the road lines, the protected regions, they are all within the boundary data, right? So we are using the boundary as the what? As the output extent, so that the raster data is not going to go beyond that boundary. Yeah. So now after doing that, the next thing that we need to do is for us to add another. We can use this plus to add another row, right? So after adding another row, we can click on this. So initially we clicked on protected regions. We've done road, right? So I will add water polygons. So after adding water polygons, all we need to do is to use this fill down. If you click on fill, it is going to autofill with the same value. So we'll do fill down. So you can see immediately I clicked on fill down, it changed this one to 1. So to take advantage of that, I will just add 2 more rows for the remaining ones we have, and then I will use fill down to autofill. So we have water polylines. So now we have the water polygons, we have water polylines, we have protected region, right? Yeah, I think another thing I'm going to do was, because when I did that first one, I didn't rename it. You can see it is showing rasterized, right? So I'm going to do that also for the roads here as well. But this time around, I'm going to rename everything, right? So now what I'm going to do is to click on this autofill and then click on fill down. They all have the same value with the first one. Just all you need to do is to set the first, and if you do fill down, it will automatically fill every other rows with the value of the first one. And yeah, so this part also, I'll click on this autofill and then fill down. You can see it's now 15. It's pretty straightforward like that, and it saves time. That's just the advantage of the batch processing. And then I'll click on this part also, fill down, and we progress to this one, science specific value to output bound. So now there's this particular one, we have to assign specific no data value to output bands. So this particular one here, I'll set it to not set. The reason was because if I do not set it to not set, right, the rasterized data will be saying 0, and that's going to be a wrong value, and our analysis is not going to make sense, right? So for any pixel that does not have a value, QGIS is going to identify that that value is not set, right? So that's basically what I'm doing. So I set this first one to not set, and then we'll take advantage of this autofill to fill every other one to not set, right? So now after doing all of this, right? So if we want to save it, right, all I need to do is to I'm going to use raster, right? All I need to do is to do raster underscore, right? Let me cancel this. So what I'm going to do here is I will use raster underscore, right? and then I will autofill this one also. So what this means is that if I do raster underscore, it is going to fill this underscore with the name of each of the data. So this one now, which is protected region, is now going to be raster underscore protected region. This one, which is polyline, I guess, which is water rather, it is going to be raster polygons. It is going to be raster underscore water polygons. The next one is raster underscore water polylines, and then raster underscore roads, right? So it's just going to autofill it, right, for the rasterized. And yeah, so now what we need to do is now for us to load layers on completion. So I'll click on this and then I'll click on run. Okay, we are missing value for row 5. Do we have row 5 there? Output raster size row 4. Missing parameter values. Okay, yeah, this one here, we didn't set this. Okay, so after doing that, right, click on run. File are not supported as output for the algorithm. File not supported as output for the algorithm. Fitable value. File not supported as output for the value. Okay, so I think this is spot. So I will use field parameter layers, right? Okay. Okay, yeah. So yeah, the value I added before was wrong, right? That was the reason why we got to this. And this is going to be saved in on our documents directory, right? So this is what we are going to name it. Remember, we said raster underscore protected region, raster underscore. So all I needed to do was to click on this part here and then click on save it, just type raster, right? And yeah, that was the where the error came from. So this processing, it is going to take some time, right, for it to load. And after it has been processed, we have our raster data sets ready for us for further analysis. Okay, so this is still loading and it's taking time. Um, but before it finish loading, do we have, is there any question? Okay, so now as it is loading, what I'm going to do is this particular one that I created before, I'll just remove it here. I'll delete it. Right, I'll delete that layer. Yeah, because I don't want to work with it any longer. So I'll just remove it. Right. Okay. And this is still loading. So this is taking time, right? Because it's a batch processing we are doing. It is not just one vector data we are rasterizing. We are rasterizing more than one vector. Okay. So you can see as they are loading, they have already started showing here, right? So we have raster water polygons here already, right? So we have the others as this loading. So we have raster water polylines. If you look at this part here, look at my cursor, you can see raster water polylines, you can see raster water polygons, and yeah, the other ones also, they are still loading. So the remaining two, we have roots and protected regions that we are yet to have. I hope you can still hear me, everyone.
Yes, we can hear you.
Hello, can you still hear me? Okay, it's all complete, right? So what I'll do now is all I will need to do is to close this particular session, right? So look at this part now. This is the raster roots. Remember, we did it initially, but we didn't rename it. But at least now it is more meaningful to us because it has been renamed. We can say raster road. And if you look at this part here, that was the pixel value we set, right? 1 for where there is road, 0 for when there is no road, right? So that's the range. I'm going to collapse this. And if you look at this part here, the raster water polylines also, right? So I'll collapse this also. So there's raster water polygons, and so for this rasterized, that's the one I will delete. That was the one I created initially. Okay, yeah. So that has been removed. Non-raster protected region, which is supposed to be here also. But yeah, we can progress on, and then because this is still have a long way to go here, right? So now the next thing that we can do is, if you look at this water polylines and water polygon, I'm just going to uncheck this, uncheck this, uncheck this, uncheck this, uncheck this, and then uncheck the road as well, uncheck this, right? So if you look at this raster water polygons, right? If you look at the visualization here, you can see how it looks. And I'm going to uncheck that and then show the water polylines as well, right? So one thing we can do is we'll merge them together, right? So the next thing that we need to do here is to merge the raster water polylines and raster water polygons because they are water bodies, right? So we'll merge them together, right? But one thing we need to consider is that as we are merging them together, remember where there is water polygons, where water body exists, the pixel is what? 1. And where there is no water body, the pixel is 0. Same thing also for polylines. That means now that if we should merge them together, there will be an issue if there is a polygon and polyline coming together, because then we'll be having a pixel of 2, right? But we want our pixel to be in pixel of 1 and 0 only. But we'll solve that, right? That's what we'll do. And this is where we now need to use the raster analysis to perform raster calculation, right? So we'll come back to the processing toolbox. Then we'll find under this raster miscellaneous, right? You can see raster calculator.
Okay, Gabriel, can you hear me?
Yeah, I can hear you.
Okay, so because of our time, you have 10 more minutes to quickly round up. If we are unable to cover everything now, we could schedule another class for it for a continuation.
Okay, basically, definitely won't be able to complete this session this evening, right? Because it's a long process for us to do all we need to do to achieve our end goal, right? So basically, now that we've converted all of the data from vector to raster data. The next thing that we'll need to do is to merge these two, right? So that's one raster calculation we need to perform, right? And after merging them, we will now need to generate proximity rasters, right? To know the distance of a region to a road. What's the distance between them using Euclidean distance? QGIS already has that feature for us, right? And another thing again that we will now need to do also, and mapping the distance, setting the distance from maybe from roads to the region. Remember, those are the criteria we are looking for. How far is a particular region, a potential region, a suitable region is to the road? How far is that region? How far is it from water bodies? How closer it is to the road? And if that region is in a protected um, region, right? So all of those will require some raster calculation, right? So I know we won't be able to do this today, right? Maybe we'll continue it in our next class. Um, Hopefully there won't be this network issues, and we would have prepared and overcome the hurdle of this network, and then just go straight to where we stopped today. I hope that works, Sarah.
Apologies, Gabriel. My network disconnected me a bit. Can you please come again with what you said?
Uh, okay, so basically, I was basically saying that we can continue next time, right? Because the next thing we'll be doing now is going to require some time, right? For us to merge these two water bodies together so that we know that we just have one water body raster data.
Oh, that works perfectly. That works perfectly. So, are you done?
And we will have to do QGIS to raster data together. And the next another thing again that I'll be doing is for us to reclassify the data, right? Remember the values we have. We want a certain distance of a suitable region to of how closer a suitable region is to the road and how far it is away from water bodies, right? So those distances are going to be calculated, right? And for us to do that, it is going to take us some amount of time, right? So what I'm basically saying is that when we meet next time, we can continue from where we stopped today. So now, basically, what we have been able to achieve is to firstly understand the problem statements, getting all of the data into QGIS layer panel, and then rasterize all of the vector data sets, which is important for us to be able to perform multi-criteria value analysis. And then we'll continue from this next week. I hope this works.
Awesome. Yes, that definitely works. Thank you so much, Gabriel, and everyone that joined the call. I want to say a very big thank you to you all for your patience, even though we had serious technical glitch. You all still stayed on the call. We really do appreciate this. So this with this end of today's class, but we would like you all to do follow us on LinkedIn, follow us on social media handles on LinkedIn, Twitter, Facebook, and Instagram at Data Science Nigeria. And as Gabriel has rightly said, we will be having a continuation of this class in our next weekly webinar series, which will be communicated to everyone on the group. So, as this is the general Data Science Nigeria community where we are hosting this webinar series, we have a dedicated group for the geospatial class, for the geospatial um, people alone. So if you are interested in joining the group, my colleague Blessing will be dropping the link to join the group on the on this. And also, if you're interested in interacting, is a community where we interact, where geospatial persons interact with each other, opportunities are being shared, and you get to ask questions that you are not and not that you would not necessarily get answers to. outside the community. So we enjoy you to please join the community. Once it shares the link, join the community, invite your friends that are also in the geospatial space or are interested in it to join the community as well. And with this, I'm saying bye bye to every one of you. Bye.